So the question is saying that figure 1 is a diagram showing the appearance of a coin immersed in water when viewed from above. So it means there's a coin here together. There's a coin down here. Aye. So this coin, there's a coin in fact here. Here. Yeah. Actually, the coin is down, but it appeared to be on this position. But the coin is down here. We all know what happens in water. For example, like when you put something in water, it always appear to be near. I mean, no, it's at the bottom. So this is the real, then it's the apparent eye. So as you can see, this is the eye. Then we have the distance for the real. The real is from here to here together. Then the apparent distance from here to here together. So the real is what is 15 centimeters high. Yes. Then the apparent is what is 11.2 11.2 or 11.2 centimeters high. Centimeters or whatever. So we'll get 11.2 centimeters high. Yeah. Then now the first question is saying state Snell's law. So what is Snell's law? We can try.
This is the ratio of the sine of the angle of incidence with the sine of the angle of refraction. Refracted wave.
Okay, and try. What do you think? No idea. Oh, but what do you think? No idea. You? No idea. Are you sure? So Snell's law it states that the angle, so that the ratio of sine incidence to sine what? Sine refraction is always constant. Right? So it states that the ratio of sine incidence, which sine I, to the ratio of sine refraction is always constant altogether. That's why we even use the formula. We say the Snell's law is equal to sine I over sine R altogether. So sine I means sine incidence, then sine R sine refraction. So this is Snell's law, right? So it states that the ratio of sine incidence to the ratio of sine refraction is always constant. We quote Snell's law altogether.
Actually, the ratio of sine incidence and the ratio of sine refraction
is always constant.
Yeah.
So this is the formula we use. So sine I, sine incidence over sine R altogether. So sine I is what? Incidence, sine R refraction altogether. Good. Then now, what happens to the rays of light at the surface of water in the figure? In this figure, if it above. So, for example, like these are rays of light. So what happens as they reach at the surface of water? What happens? Yes, what happened? Are this arrow going inside or outside?
Outside.
Okay, so what happened? What happens to the rays of light at the surface of water in figure above?
They refract.
They refract? Any idea? What happens to the rays of light? Okay, for example, like as you can see the arrows, the arrows here are showing that the rays of light are moving from the denser medium. This is the denser medium, which is water. So as they reach at this point, since they're moving from denser medium to less denser medium, so they'll be refracted away from the norm altogether. But for example, like if the rays of light was coming from air here, then to water here, as you can see, which means they'll be reflected toward the normal. So now we'll say the rays of light will be reflected, Are together? So they'll be reflected. So they'll be refracted. Clear? So they'll be refracted, okay? Then you calculate the refractive index of the water. So in short, they want us to find the refractive index. So what if my refractive index?
N is equal to sin I over sin R.
Okay, yeah. So you can say sin what? Sin I over sin R. Now on this one, we cannot use it because we don't have angle of incidence, we don't have angle of refraction. So the best formula to use it, this one where we say the refractive index is equal to rho. How together? Rho what?
Rho image over apparent depth.
Apparent.
Rho depth over apparent depth.
Over what? Apparent, yeah. Okay. So our rho is the distance from here up to here together. I mean from here up to here. We call it rho over apparent. So the rho is from here to the bottom of the liquid. So from here to here. So what is the distance from here to here? 15. So we put 15 here. So it's equal to 15 over the apparent distance from here to here, which is what 12.5, 12.2, 12.2, 11.2. Okay, 280. There's 280 at the end. Okay, 280. Good. So that's 280. Okay. Then now, how do you find here? So you divide that. So 15 divided by 11.28. What is that? 1.32 97 872. Okay, so we'll say 1.3, just like this. That's the final answer. This will be our refractive index. So we say real depth over apparent what depth, which means real is 15 from here to here, from here to here together. Then apparent is the distance from here where you are able to see the coin together. So from here to here, apparent, real from here to here. Is it clear? So these are our final answers. Any question? Question. But don't forget that you can also use this. But on this question, we cannot use this formula where I say sin I over sin R, right?
Yes.
Because we don't have angle of incidence and angle of, so which means we can use this formula or this formula. As at now, yes, we can just use this formulas. But also can you measure image over time as we proceed. So, but for now, we can just use this formula, these two formulas: sin I over sin R, and also real over apparent. Yeah.
Nanga process tunashtia correct into business.
So you put 3 here. Okay, there's no problem. Yeah, there's no problem. Like this. Clear?